Yes, Akshat. So everything is okay?
Yeah,
Okay. Uh, in the last class, we learned about the matrices, right?
yeah.
We saw the introduction part of matrices, right?
Hmm.
Today, we will learn the types of matrices, okay?
Okay.
So give the heading types of matrices,
Hmm.
okay?
Hmm.
The first type is column matrix, okay?
Hmm.
It's too easy. Just you have to remember or understand the concept. Okay.
Yeah.
Hmm. Uh, by the name, as you can see here, what it is written here, it is
Hmm.
what is written here. What type of matrix?
Column matrix.
Column matrix. So by the name, you can easily understand it. A type of matrix which consists only one column, okay, or a single column. So that type of matrix will be known as, tell me.
Like a
Hello?
single column
Column
matrix means
matrix.
only the column.
Column
Like,
matrix. Okay. So we will
yeah.
say a matrix is said to be column matrix. Okay. Column matrix if it has only how many columns? So only don't write now, है ना? First try to understand it, okay? I will give the separate time for
One.
writing, okay? First try to understand the concept.
Okay.
Otherwise, you may become confused, okay? So what I said here, कि if it has only how many columns? What we will write?
Hmm. One.
One column, okay? It has only one column. So that type of matrix is known as, it is known as
Column
column
matrix.
matrix, okay? Yes. Now let's see here as an
Hmm.
example. Suppose there is a matrix A, okay? And the elements are A,
Hmm.
B, and C, okay? So as you can see here, how many columns you can see here? How many columns are here?
Three.
Uh,
Three.
there are three rows, not column. है ना? There are three rows. The
Okay.
first row
Yeah.
is
Three
row of A,
rows.
second is B, third is C.
Hmm.
But the column is only one, na? The
Yeah.
vertical column means
Yeah.
you have to check it as
Yeah.
vertical
Yeah.
wise. Row means horizontal wise. Okay.
Yeah. Yeah.
So when you will see it
Three
horizontal wise,
verticals.
it will
Yeah.
total three rows. But in column wise,
Hmm.
it has only one row.
Only
Okay.
one.
Yes. So that's why it is column
Yeah.
matrix. And if we will write the order of the
Hmm.
matrix, then it will be, what will be the order? We learnt it in the yesterday's class. The order is m by n, है ना? M
And
by
M to
n,
N.
right? Yeah, m by n. It is read as
M.
by, it is read as m by n. Okay.
M
So
by
m
N.
is the number
Hmm.
of row and n is the number of columns. So
Those
first we have to write the number of row. What is the number of row?
three.
3. And number of column? Number of column?
One.
1. So it will be 3 by 1. Matrix of 3 by
One.
1. Okay.
One.
Is it clear? Similarly, the another example, suppose there is a
Yeah.
matrix B, okay, whose elements are 1, 2, 3, and 4. Okay. So how many rows you can see here?
Hmm.
How many rows it has?
Hmm. Four.
4.
Four.
And the number of column? Number of
One.
column? 1. Right? So it is 4 by 1.
One.
Matrix of order 4 by 1.
Yeah.
Right? So here we can say that when we have to write the standard form,
Yeah.
okay, of this matrix, then we can write it A equal to, A is a matrix whose
Hmm.
element will be A I J, okay, A I J M into 1. The order will be M into 1, okay. It's mean a matrix which has only one column. That type of matrix is known as
End to
column
end.
matrix. Is it clear or any doubt? By the name you can easily understand it,
Got it,
okay.
sir. Yeah.
If you will
No doubt.
forget, if you will forget it, then you have to just remember the concept, or you can also remember it by the name. Column matrix means a matrix which has only one column, so that type of matrix is known as column matrix, okay. It is too simple, right?
Sir, won't that be 1 into 1?
What? 1 into 1, it will be
Like,
square matrix, na.
won't that be?
1 into 1, it will be a square matrix, okay.
Yeah, but
Yeah.
there's only one
Yes,
element
yes,
there,
that
so.
thing we learnt later, okay. That thing we learnt it later,
Okay.
okay. You ask the question, that is the very good thing, okay. So I will
Hmm.
discuss these things, or I will clear your concepts will clear on this point when we will learn the square matrix, okay. So slowly we will go it.
Okay.
For we will learn about the column matrix, then we will learn about the row matrix, and when the column and the row become same, then that type of matrix is known as a square matrix, because they form a shape of a square. I think this part we have discussed yesterday, है ना. You asked about cubic matrix,
Hmm.
right? You have a doubts, there
Yeah.
is a cubic matrix, so I explained no, that is not, there is no any cubic matrix. That is
Okay.
also known as a square matrix, because
Square
it
matrix.
is 3 into 3, na, you told me, right?
Yeah.
So 3 into 3 means
Yeah.
3 row
Yeah.
and 3 column. So when you will form it, it will form a square, okay. So that's why that matrix is also known as a square matrix. So similarly 1 into 1 will be also known as square matrix, okay. So first
Hmm.
focus here. Did you understand the meaning of the, or the concept of the column matrix? Is there any doubt in
Yeah.
it?
No doubt.
No, then please note down it. After this we will move toward the next part. Okay, noted. Is there
Yeah.
any doubt?
No doubt, sir.
Now let's see here. It's about row matrix, okay. So I think you can explain it by yourself, right? As in the column matrix,
Hmm.
we learned a matrix which has only one column, that will be known as column matrix, right? Similarly, can you
Yeah.
explain a row
As
matrix
a
by yourself?
matrix
Hmm?
is said to be a row matrix if it has only one row.
Yes, when it has only one row.
A
Okay, so that
matrix is said
hmm,
to be one row. Yeah.
be row matrix. Okay, row matrix, not raw. It's row, ROW, row matrix. Okay, row matrix. If it has, if
Hmm.
it has only how many rows? So only
Row matrix.
how many row it will have?
Only one row.
It yeah, it will has
One.
only one row. Okay,
One.
so it has only one row. Okay, is that clear now? As an example, you can see here. Suppose there is a matrix A whose elements are A, B, C, D. As you can see here, all elements are in a
Yeah.
single row, right?
Hmm.
So here the number of row will be 1, and the number of column will be, how many columns you can see here? Column is vertical wise. You have to check it vertical wise. So how many it will be? How many columns it will have? Hello, Akshat, can you hear me?
Hmm.
Yeah, please tell me how many column it has. Hello. Hello.
only.
Hello, Akshad.
Sir, only one.
No, no, I'm talking about the column.
One.
Number of column, not the number of row.
One, sir.
Yeah, I am
Hello?
talking.
Sir, I can hear you. Hello?
So I am talking about the number of column, not row. The row is
Yeah.
only one. Okay?
Yeah, sir, it's one. I said
Huh.
one.
But number of column,
Yeah.
number of column,
Four.
4.
For
Very
four.
good. The number of column is very good. So the order of this matrix will be 1 by 4. Okay? Is it
Four.
clear? Similarly, we can take another example. Suppose there is a matrix B which whose elements are
One into
P,
four.
Q, R. Okay? So here again the order will be 1 by 3, right? Number of row is 1 and the column is 3. P, Q and R. Okay, vertical wise, right? So
Yes,
here
sir.
the general form of this raw matrix will be Aij. Okay, it will be one row and n column. Okay, it may has more than one column. Okay, but the number of row will be only one. Is it clear now? So please note down this. After this, we will continue with our next part. Okay, so is it clear now?
Yeah.
Now let's see here. It's about a square matrix. Okay, square matrix. So it will be when the
Hmm.
number of row, okay, means m, it will be equal to number of column, okay, means n. So when m is equal to n, that type of matrix is known as a square matrix. Okay, is it clear?
Yeah, now I
So,
can.
huh, when you have to explain the square matrix, you can say that a matrix is said to be a square matrix when the number of row is equal to the number of column. Okay, or you can say
Okay.
if it has number of row is equal to number of column, so that type of matrix is known as a square matrix. Okay, it will be known
Hmm.
as a square matrix. As an example, you can see here suppose there is a matrix A and its elements are A, B, C, D. Okay, so as you can see here, the number of row is, what is the number of row? In one row it is A and B, and in the second row it is C and D. So total number of row is 2, right? And number of column is, let's see here, in the first column it is AC and in the second column it is BD. So it will be again 2. So as you can see here, the number of row
Hmm.
is equal to the number of column. So that's why this type
Two.
of matrix is
Two.
known as a square matrix. Okay.
Yeah.
Now in the second example, let's see here. Suppose there is a
Two
matrix
into two.
hmm, uh,
Yeah.
P Q R. Okay. S T U and here V W X. Okay. This is a matrix. So let's see here the number of rows. In the first row it is PQR, in the second row it is STU, and in the third row it is
Yeah.
VWX. So number of row will be Akshad. What will be the number of row? Hello.
Three, sir.
Yes, it will be 3. Okay. And the number of column will be, let's see here, the column. First column is PSV, second is QTW, and the third is RUX, right? So the number of column will be also 3. So as you can see here, the number of column and the number of row are same. Okay, so that's why this is known
Three.
as a square matrix. Okay, now let's see the example. C. Suppose there is a matrix which has only one element. Okay, um, you can take it as A, 5, 1, anything. Okay, I take the element as 1. So here you can see ki the number of row means when you will see the horizontal wise, it has only one element, right? Number of row will be 1, and the number of column will be also 1. When you will see, when you will check it, the column wise. Okay.
Hello, sir.
Yes, I'm audible.
Sir, your voice, like, everything was delayed.
Oh, yes, I also
Like,
felt because you
yeah,
were responding too late.
yeah,
Now is it okay, na?
yeah. Like when you were speaking, you were already starting the next one in the said screen.
Oh, means I think the voice and the presentation are lacking. That's why.
Yeah,
Okay, okay.
yeah.
Okay, let's see here. So these two are the examples of a square matrix. Okay, the
Hmm.
first is the square matrix of 2 by 2, and the
Yeah,
B matrix. The second matrix is the square matrix of 3 by 3. Okay, now we will see
yeah.
a matrix which has only one row and one column. That was your doubt, right? Yes. So see here, it is the matrix of one by one, because when you will check it in the row wise, it has only one row, and when you will check it column wise, it has only one column. So that's why it will be one by one. है ना? The order of the matrix will be one by one. Okay, and it will be also the example of square matrix. Is it clear or any doubt? So what will be the general form? What we can say that A equal to Aij m into n, okay, where m is equal to n. This one you have
Hmm.
to always write whenever you will write the standard form of square matrix. Always you have to write ki where m is equal to n. This is the very important part,
Okay.
so always mention this part, okay, otherwise it will be
Yeah.
wrong. Okay, so where m is equal to n. Is it clear now or any doubt in this one? Okay, so please note down it.
No doubt, sir.
Yeah, okay, please note down. Done. Yeah, done now.
Yeah.
Okay, let's see here the fourth one. Okay, it's diagonal matrix. Okay, diagonal matrix. By the name, you can easily remember it, as here it is written diagonal, right? So a matrix in which uh, all the elements will be in the diagonal. Okay, all the elements will be in diagonal.
Hmm.
Rest all other elements will be zero. Okay, so that type of matrix will be known
Okay.
as diagonal matrix. Let's see how we will write it, standard definition. So we will write a square matrix, a square matrix. Okay, suppose the matrix is B, element is B ij, m into n. It is a square matrix. Okay, we have to let it as a square matrix. Is said to be diagonal matrix. Okay, diagonal matrix if all its non-diagonal non-diagonal elements are zero. Okay, are zero. That is, we can say that ki b is equal to bij. Okay, a diagonal matrix. Okay, our diagonal matrix if bij is equal to 0, if I is not equal to z. Okay, if I is not equal to z, then that type of matrix will be known as diagonal matrix. Now here there are 2 3 points which you have to know. Okay, before that let's see an example. Suppose there is a matrix. Okay, so as here we learned a point, when you will notice it in the first line, as you can see here, a square matrix is said to be diagonal matrix, right? Means the diagonal matrix should be a square matrix, right? Then only we can form the diagonal, na? Right? So the in square matrix it's formed diagonal, right? As here you can see in A, the matrix A, the diagonal elements are AD and the other diagonal elements are BC, right? Similarly here the set B, the diagonal elements are PTX, and when you will see the diagonal from the right corner, upper corner, it will be RTV. Okay, so it should be a square matrix. Okay, a square matrix, then it will be a diagonal matrix. Okay, so every diagonal matrix is a square matrix also, we can say it like this. Okay, but square matrix may or may not be a diagonal matrix. Okay, because as you can see here, in the above examples A and B which we have taken in a square matrix, see here, as you can see, ki the non-diagonal elements are not zero. Okay, when the non-diagonal elements are not zero, then it will be not a diagonal matrix, na? The non-diagonal elements should be zero. Okay, then only it will be known as the diagonal matrix. Okay, so as an example, suppose we have a matrix A whose elements are A, 0, 0, 0, B, 0, 0, 0, C. So as you can see here, the diagonal elements are non-zero elements and the non-diagonal elements are 0. Okay, and it will be of 3 by 3 matrix. Suppose there is another matrix B, 5, 0, 0, 5. As you can see here, it is the matrix of 2 by 2, which is a square matrix, and here the diagonal elements are 5 5, which is non-zero, other are 0. Okay, similarly here the standard form, the standard form we can write it as, okay, with the all elements, a11 0 0 0, a12 0 0 0, a13. Okay, so a11 a12 and a13 are non-zero elements, they are non-zero elements. Okay, so this type of matrix will be known as a square matrix, sorry, diagonal matrix. Is it clear? And as you can see here, the all diagonal matrix are a square matrix, but a square matrix may or may not be diagonal. So as a note you can write this point. Okay, all diagonal matrix are square matrix, but all square matrix may or may not be a diagonal matrix. Okay, because in the diagonal matrix it should be the non diagonal elements are 0. Okay, so you have to keep this point in mind, and I hope it is clear, right? Okay, so please note down it, and when you will done, then please tell me, I will scroll it. Okay, is it clear now? First note down it, and then the examples. Okay, so please note down. Okay, so now let's see here. We'll learn about scalar matrix. Scalar matrix. So it said that a diagonal matrix is said to be a diagonal matrix is said to be a scalar matrix. Okay, scalar matrix. Uh, if its diagonal elements, diagonal elements are equal. Okay, are equal. So let's see here as an example. Suppose there is a diagonal matrix. And one more point, as it is diagonal matrix, it's mean it is also a square matrix. Okay. So 5 0 0 0 5 0 0 0 5. As you can see here, the diagonal elements are same. Okay. So that's why it will be known as a scalar matrix. And it is a matrix of order 3 by 3. Now the second example is, suppose we have a matrix A 0 0 A. So as you can see here, the diagonal elements are same, okay, which is A. So that's why it will be a scalar matrix. So mainly the few points which you have to keep in mind, a diagonal matrix, first of all, it should be a diagonal, and if it will be a diagonal, it's mean it will be a square matrix. Okay, ultimately it will be a square matrix. So a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Okay, is it clear now? So, and the few points, the more points are, we can say that the scalar matrix, all scalar matrix are diagonal matrix, and we can also say that all scalar matrix are square matrix. Okay, but the reverse is not, may or may not be true. Okay, is it clear? First note down it, then we will continue with the identity matrix. Okay, yeah. So done. Okay, let's see here. Hmm. Now let's see about the identity matrix. Okay, identity matrix. Here, a diagonal matrix is said to be is said to be identity. Okay, identity matrix if its diagonal elements are diagonal elements are 1. Okay, and rest all are 0. All are 0. As an example, suppose there is a matrix A and the elements are 1 0 0 0 1 0 0 0 1. So it will be the matrix of order 3 by 3. Let's see here. First of all, the identity matrix means it should be a diagonal matrix, and ultimately it will be a square matrix also. Okay. So diagonal matrix is said to be identity. By the name you can easily remember it. Identity. Identity means 1. Okay. So its diagonal elements are 1. If so all diagonal elements will be 1, then this type of matrix will be known as identity matrix, and rest all elements, non-diagonal elements, will be 0. Okay. Is it clear? So ultimately we can say that the identity matrix, all identity matrix is a square matrix, all identity matrix is a diagonal matrix, and we can also say that ki all matrix identity matrix is a scalar matrix, because you can see here, as you can see here, the diagonal elements are equal, okay, are same, okay, but the reverse may or may not be true. Is it clear? Now let's see the another one. Example 1001. It is the matrix of 2 by 2, which is a square matrix as well as diagonal matrix as well as scalar matrix. And after that, as you can see, the diagonal elements are 1, so that's why it is also known as identity matrix. One more, C, a matrix whose element is only 1. Okay, it is the matrix of 1 by 1, so it will be also as identity matrix. Okay, is it clear? First note down it, then we will continue with the zero matrix, the last type of matrix. Okay, please note down it. Then, so now let's see here the last type. Yes, so let's see here the seventh last one, zero matrix. Okay, so a matrix is said to be zero matrix. Okay, if all its elements, if all its elements are 0. As an example, you can see here, suppose there is a matrix A of order 2 by 2. So here we have to keep all the elements as 0. Okay, so this type of matrix will be known as 0 matrix. Okay, suppose B is a matrix whose all elements are 0. This is the matrix of 3 by 3, so it will be also known as 0 matrix. There is one more. Suppose there is a matrix of order, as the row is only 1 and the column is 2, 1 by 2 of 1 by 2. So this matrix is also known as 0 matrix. Okay, so here we learned about the types of matrix. In this we learned about column matrix, row matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, and 0 matrix. Okay, so for this class, that's all. I hope you understand. After this, we will continue in the next class. So, for today, that's all. Thank you. Take care.